Hi everybody, just get used to the accents. You'll be hearing it for 5 minutes. I'm Dawn, and I'll be presenting about multi-scale analysis of crime and incident patterns. So how do we do it? We could do it using a combination of visual inquiry tools as well as cluster detection and spatial scan statistics. But we should apply a progressive deepening approach to compensate. If we don't think about the scale effects, the kinds of relationships and stuff that we could get are directly impacted by the type of spatial and temporal granularity that you choose. So we can look at some of the different methods that we could use to do this. Kernel density estimation is quite a popular one. Here we did planar as well as network kernel density estimation. And the pattern that you see are what you would expect for the area of Camden, the hotspots in Holborn as well as in Camden Town. So if we take just a little bit more detailed look at it. This is a detail of the Holborn area, which isn't as intense as the Camden area, but we see hotspots around different places like tube stations and so on. And if you look at how it varies according to the dates, you would realize that routine activity theory does come into play because in Holborn, the resident population is much lower than the ambient population. I used to live there, and I thought it was completely dead until I went out one day at lunchtime and I was like, where did all these people come out? So you would notice that. As well, crime goes down on weekends. Yeah, just a detail look at Camden Town is a hot point right close to the tube station in Camden. Hold on. So if we, let me go back up. Right. So we could use different visualization methods to do this. These were alluded to before. Here we have a space-time cube with a scatter plot of all the different points in the region. It's much better if you could look at it interactively. You could zoom it around and stuff, and you could actually see the clusters happening. I just put different colors according to the different weeks of the study to make it a little easier. You could also introduce bar lines. That will help a bit. So with the spatial scan statistics, you have a cylindrical window moving through the area. And what you do is you use a particular model, and you count the number of points within the cylinder and as compared to the number of points expected. And that's how you define your clusters. So in the end, you get a series of overlapping cylinders. And so a crime hotspot is a cylinder where the number of crimes are statistically significantly larger than to be expected. Two methods were used, the space-time permutation model and the space-time Poisson model. The space-time permutation model, unfortunately, didn't find very useful results, but the Poisson model found just what we expected from the kernel density estimation. We see a hotspot here in Holborn as well as in Camden Town. Both of them have a duration of 2 weeks, but their start times and end times are different. We will also see that the hotspot in Camden has a greater relative risk, and that's why it's in red, and the one in Holborn is more dispersed, as we saw, and a lower relative risk. Yep, so that basically says that. We could also use the self-organizing map method, which is wonderful because it allows you to introduce also the attributes of the area that you're looking at. So you could also look at crime in terms of deprivation or crime in terms of anything you wanted to, which is good because when you're looking at things like crime where it affects a population, you need to use the right population. So you wouldn't want to be looking at crime as I mean, you could look at like vehicle crime with people, but it's better to look at vehicle crime with the number of cars. So that's it. The self-organizing map method allows you to do all these things and is wonderful with different types of visualization. Once you get around reading them, because they aren't the most easily interpretable, it's very useful. That's it. Thank you.
Very good.